Welcome to the RhinoCAM Quick Start tutorial series brought to you by MecSoft. Today we'll be demonstrating RhinoCAM Mesh. Before we begin, let's talk a bit about the RhinoCAM display. When you run RhinoCAM for the very first time, your screen may look like this. These windows on the left belong to plugin modules that are currently loaded. For now, let's close them all. Okay, let's go ahead and load the RhinoCAM Mesh plugin. So from the main menu in Rhino, we'll select the RhinoCAM main menu, drop that down, and we'll pick Mesh. And it displays the Mesh browser on the left, and the browser is divided into three different areas. We have a ribbon bar at the top, and we have a data tree in the middle where all of your mesh objects are located, and we have an information portion at the bottom of the browser, which also serves as the command options window. We'll be performing the following steps to complete this guide. First, we'll open a point cloud file. Then we'll create a mesh from the point cloud. Then we'll auto-fix the mesh and analyze the mesh. After that, we'll refine the mesh and smooth it out. Then we'll analyze the mesh using curvature and reflection analysis. Then we'll create and analyze slice curves from the mesh. Finally, we'll create an offset shell and then split the mesh into two halves. So let's go ahead and load our point cloud data file that we're going to use to create our mesh from. So we'll go ahead and from the Rhino standard toolbar, we'll pick Open. We'll select rubberduck.csv, which is a point cloud file. And we'll go ahead and select the default options for importing the point cloud. And you see that we have a point cloud loaded in Rhino, and we have a point cloud object listed over here under the data tray. So the first thing we're going to do is we want to create a mesh from the point cloud data. So while the point cloud is selected, let's go ahead and we'll go ahead and go to the Create tab. We'll pick Create from Point Cloud, and we'll select the default values. If you want to use different values when you go through the Quick Start Guide, you can adjust those. But we're going to use the default values for the video. So we'll go ahead and pick Create. And let's turn off a point cloud, and you see that a mesh object was created. And let's go ahead and under the display, let's go ahead and turn off the mesh wires. And let's go ahead and select our rendering. So we have a nice, not really nice, but we do have a mesh from the point cloud file. And the reason, obviously, we selected this point cloud is we knew that it was going to be a not so perfect mesh. And you'll run across this when you create meshes from point clouds where the data might be missing in certain areas. So that's where the mesh module comes in handy. So let's go ahead and do an analysis to take a look at what we got. Let's go to the Repair tab, pick Diagnose, select our mesh, and we'll run the checks. And we see that we have over 1,200 open edges. We want to fix those. It's obviously not real smooth, so we knew that ahead of time. So let's go ahead and cancel that. And now that we have it shaded, let's go ahead and turn the mesh wires back on, and you'll just see what we have to work with here. So we have a mesh that's got a bunch of holes in it. So let's go ahead and let's do auto fix on this mesh. Now the mesh module has a lot of commands on the Repair tab that you can use to diagnose and automatically and manually fix your meshes. So we're going to use auto fix for this. And we'll go select our mesh, right click, and it automatically closes all the holes in the mesh, makes it a watertight mesh model. So you can see, if we zoom in, you see that the holes that we had in it are all closed up. Let's do another diagnose. See that we have 0 open edges. That's good. So now what we want to do, we have a closed mesh, but it's not real pretty. It's not smooth, it's not even. So let's go ahead and remesh the object, see if we can get this looking a little bit better. So we're going to go to the Inspect and Modify tab. We'll pick Remesh, select our mesh, and we'll select the uniform option. With the edge length, we'll use 0.1, and we'll do it in 5 iterations. It means it'll remesh it, then it'll go back over it and remesh it again 5 times. So there's our remesh. You see that we have a uniform mesh. It's not real smooth. It's kind of bumpy. Doesn't look too great. Looks better than it did. So let's go ahead and smooth this out a little bit. See if we can get it looking a little bit better. So we'll pick Smooth from the Inspect and Modify tab. Select our mesh, and we'll allow it to deviate in both directions. We'll do 10 iterations this time and pick Smooth. So now you got a nice smooth looking mesh from that point cloud. Everything looks uniform, just a few imperfections, nothing real critical. Let's go ahead and analyze this mesh to see a couple of other ways that you can look at it. So let's go up on the Inspect and Modify tab. We'll pick Reflection Lines, pick the mesh, and then we'll pick Render. So what you see here is you've got a rendering placed on top of the mesh model that allows you to see reflection characteristics of the mesh model. And you can use this to zero in on areas where you might want to do some more refinement. And you can also do a curvature analysis. This was reflection line analysis. Let's select curvature and pick Analyze. So you can see it displays the extreme curvature regions in a color scale model. Okay, so what did we do? We loaded a point cloud file, we created a mesh, we automatically fixed the mesh or healed the mesh, and then we remeshed it, make it uniform, and then we smoothed it out to make it smooth, and then we analyzed it. So what we're going to do now is you can create slice curves from this mesh to further analyze the mesh geometry. So we'll show you how to do that. We'll go to the Model tab, we'll pick Slice, pick the mesh, and for the distance between each slice, we'll leave that set to 1/8 of an inch. We'll pick Slice. Now in order to see this better, you see that there was a slice object added to the data tree. So let's turn the mesh off for a minute. And you see our slice geometry. And then also it analyzes those curves, and it'll let you know if any of the curves are open. Everything is closed. That looks good. So let's go ahead and turn the slice off for now, since we don't need that. We'll turn our mesh back on. Now what we're going to do now is we're going to offset the mesh, and then we're going to split it into 2 halves. So we're going to shell it and then split it. To do that, let's go ahead and first rotate the mesh over on its side. So let's go ahead and select the mesh, and we'll use the Rhino gumball to rotate the mesh, and we'll enter -90. So that rolls it over onto its side. So what we're going to do now is we're going to offset the mesh, and we're going to select Offset from the Model tab, pick our mesh, and for the offset distance, we're going to go an inward offset. So we'll go -0.1 for an offset width, and for a tolerance, we'll say 0.01, and we'll do offset. So what we have now is we have 2 meshes in the data tree. We have our inside mesh that we offset from the outer mesh, as you can see that very well, and then we have the outside mesh, which is our original mesh. So now what we want to do is we want to split the mesh, both meshes, on the XY plane to create a top half and a bottom half. So let's go ahead and we will pick the split command from the modify tab. Window select both of our meshes, and you'll see that it displays a split plane in the Z-axis, and you can move this split plane up and down, and if you zoom in you can see the cross-sectional split that gets created, and it'll move with you as you move this up and down. So let's go ahead and pick the cap results option, which will make a closed mesh on each half, and we'll pick split. So now what we have here is we have a top mesh, a bottom mesh, and we still have our slice curves. So let's go ahead and turn one of these off. We'll go ahead and turn off the bottom mesh. Well, let's turn off the top one so we can see the bottom one better. And let's turn off our mesh wires. So we have a nice uniform offset shell of our mesh, and then we split it in half so that we have two halves of this mesh model. This completes the quick start tutorial for RhinoCAM Mesh, brought to you by MecSoft. For further assistance, you can visit the online help supplied with the program or visit www.mecsoft.com for additional tutorials. Thank you.